Hello, how are you? Good morning, good afternoon, good evening. Let's get our cup of coffee and start very well. We continue with the resolution of exercises of integrals. In this case, we have a very particular one, which is x multiplying to the square root of x squared plus 9. And in this case, it is important to highlight that when we have square root, it must be placed as if it were, or if we had an exponent agree, it would be left to us. Then the integral of x multiplying to x squared plus 9 raised to 1/2 of x agree. I hope everyone remembers that a square root is equal to raising that part that is inside the root at 1/2. Okay, and square root, we are talking perfect in this case, so as not to lose the continuity of the other episodes. We are going to define how many terms we have. We have 2 terms, okay, because we already know that this x goes with the du. And in the next step, we will choose one of these terms as u, generally u, or we almost always take as the part that has the term that an exponent has. In this case, what has exponent is 0. One medium agree, x squared plus 9 to 1/2 perfect, and then we would choose to wear it with orange color. U equals x squared plus 9. Y without 0, 1 medium. Remember that when we use a u, that we choose a u within the terms of an integral, we leave the exponent out agree. Very well, that they only let's evaluate if the differential is complete, perfect, in this case princesses, or rather we said that this part is our then we are assuming that this is our du agree. Very well. Then what is our du to check if we have it complete derivative of x squared plus 9? How much is derivative of 1/9? In this case, of a number is always 0. Derivative of x squared. What is 2x2 x dx perfect? Very well, let's visualize to see if we have it complete. It seems to you very well we have here dx dx. Well, we have x dx. While we have this 2, we do not have it. But in this particular case, we are missing one number. We are missing number 2. And we already know how in the episodes that it is possible to add numbers. It is not possible to add variables. It is not possible to add trigonometric functions. The only thing that can be added within an integral to complete the differential is a constant. Well, in this case, it is the same thing, a number. Yes, perfect. I will proceed to copy again the integral at the bottom, and to exemplify and make everything clearer, we would then have, I will accommodate factors, only agree. I will accommodate at the beginning, which is what we took as ux squared plus 9 and raised to the 1/2 that will multiply to x dx observe, which is exactly just like what we had at the beginning. It is the same as this part we have here. It's just like this part we have here. These 3 are the same. It simply accommodates the factors. Very good. Then we need 1, 2. We agree. Yes, is what we are talking about just now. We have x dx, and what do we need? 2x dx, perfect. Let's add 0, 2. If we add it here on the outside, we had discussed that it must be added as 1/2 in order to balance it. Agree? Yes, perfect. We have 0, 2 in the numerator. We are going to place it on the outside. In the denominator, perfect. In this case, we have complete differential that where it takes us leads us to be able to make use of the chain rule for people who have already forgotten the chain rule. Remember that it is u to the n plus 1 between n plus 1. Okay, well, this is the perfect chain rule. Why we can use it? Remember, let's do there. One of the information we have seen in the previous episodes, we are going to do. Let's remember the information we have seen very good. In order to use the chain rule, it is necessary to have a u and have a complete dua, complete differential. What is our differential? 2x dx. Yes, the differential is the one we have here. Very good. We did not have it complete, but we were able to complete it with a number 2, add 0, 2, and add 1, 1/2 outside. Perfect. In this case, what do we have left? It remains for us to simply replace. Let's go to the left side and how the snow would look on us. I'm going to put it in green. It would remain to be multiplied this 1/2, which is what we got from the integral, and is going to multiply to what? To our u, but our u with the n agree, x squared plus 9 high at 1/2 do agree. At the time, we are going to make use of the string rule. It is important that you visualize that. If we take this as this thing, I'm locking up with purple color, it becomes our n. Then we have 1/2, and the chain rule tells us that 1, 1 must be added to it, between 1/2 plus 1, between 1/2 plus 1. Agree, we close in here, only because we add the integration constant. Well, something that should be clear whenever we can, we must simplify always. Always, always, always. Okay, what we can simplify. So in this case, quite a few things. How much is 1/2 plus 1? 2. And on the denominator side, how much is 1/2 plus 1 as well? And it must be multiplied by 1/2. That is in the part external. We are going to reposition before putting the final result would be 1/2 plus 1d squared plus 9. How much is 1/2 plus 1? Son 3/2 between 3/2. Perfect. We close and we add the integration constant. It is possible to simplify more. It is possible to simplify more. how we would look. We have 1/2, and that will multiply how we get rid of the part of the denominator, the 3/2, to see how it would look on us. We would have 2 left to multiply a x squared plus 9 to 3/2 between 3. We close more. We are done. We can simplify something more. If we can simplify something more, how it would fit us. We would have 1/2 more. We open, will multiply to 2. How we convert x squared plus 9 raised to 3/2. That 3/2. What can we do with it? We can put as root dx squared plus 9 cubed and all that. Between 3, we close and put more c plus the integration constant. That's it. We finish. Can be simplified more, of course. It can be further simplified. I will still place this in a different color because everything that is recorded must be multiplied by 0,1 medium and this one. So it is at the top and 0,2 by the denominator. Perfect. How the result came out this way. We would have 2 that multiplies at the root of x squared plus 9 cubed, all that between 2 times 3, 2. We would have 6 left plus the integration constant. Okay, perfect. Now we would have the solution of the full exercise of x multiplying to the root of x squared plus 9 of x. Okay, in this case we can highlight several important things. Okay, k emerged in the solution or in the solution process, in the process of finding the exercise. Solution, very good. We always separate by factors. And we also mentioned that how to know which one to grab, as u and y is commonly taken as the part an exponent has, or the term an exponent has. We check the differential, and we see if we have this complete differential. If we do not have it, we can complete it with some complete number, only with numbers. In this case, we could complete. We added 0,2 in the part, add 1/2, in order to balance the external. Ele integral. And we realized that we could use the chain rule. Okay, we realized that we can use the chain rule in this case. What we had left was to replace u to the n plus 1 in n plus 1. And in that particular case, we were left with 1/2 plus 11. In the following episodes, I am going to leave a special one there so that I can explain to you the part of the sum of fractions, or a fraction plus an integer in this case. 1/2 plus 1. We had 3/2 left, but that's all we had left, divided by 3/2 and multiplied by 1/2 that we already had on the outside. Very well. From there we pass that. 0,3 media becomes a square root, and everything inside the root raised to the cube. We had nothing more to do than multiply by the fraction we had on the outside, which is 1/2 for all that had given us that part of the startup of the chain rule. And we conclude with that the solution is 2 by the root square of x squared plus 9, all that raised to 36 plus the integration constant. Perfect. I hope it is clear. I hope so. Doubts arose throughout this process of finding the solution have been resolved. If it has any comment, please place it in the part lower and also below the video. There is information in case you want to contact me. If you have an exam next, if you have any questions about any exercise, you can contact me through there. Take care of yourselves, drink coffee. See you at the next one. Thank you.